Welcome to Math Studio Talk. The purpose of these videos is to help you interpret what students should be able to do and understand to meet the demands of Common Core math. We will demonstrate various games, activities, and models that can be used within the structure of a formal lesson plan to develop flexible thinking and deep understanding. And of course, we'll show you the math. Hi, I'm Nick Timpone, and in this video I will deal with the numbers and operations in base 10 domain for 5th grade. This work builds on the work done in the NBT and NF domains of 4th grade. As you can see, students will extend their knowledge of place value to understand the result of multiplying and dividing by 10, and they will work with the 4 operations with decimals. All of the standards in this domain are important. In the time we have, we will only be able to examine the content of some of them. Let's look at 5 NBT 2. Okay, we have 3 things to do within this standard, and the work done in the previous standard leads nicely into it. First, we have to get the students to understand the pattern of zeros when multiplying a whole number by 10 and powers of 10. Then we have to get students to see the movement of the decimal point when multiplying and dividing by 10 and the powers of 10. And finally, we have to introduce exponent notation. Let's build numbers with number chips. Let's build 23, so that's 2 10s. And 3 1s. And the students are building these. And we say times 10. Now we're going to use the chips to make that multiplication happen. Students know how to multiply by 10. They know 10 times 10 is 100. They know 10 times 10 is 100. They know 1 times 10 is 10. 1 times 10 is 10. 1 times 10 is 10. Have them record the result. 23 times 10 equals 100, 200, 10, 20, 30. 230. Now have them build the next number, 23 again. But this time we're multiplying by 100. Students know how to multiply by 10 and 100. 10 times 100 equals 1,000. 10 times 100 again is 1,000. 1 times 100 is 100. 1 times 100 is 100. 1 times 100 is 100. Now have them record what they built. 23 times 100 equals 2,300. Now we're going to move away from the chips and just do it with numbers. Have them write the number 23 again. And we're going to multiply by 1,000 this time. And you want the students to look at the pattern of the zeros in the model to try and determine what the solution to this problem is going to be. So they'll turn and talk with their neighbors. You'll have a whole class discussion. You'll think about it a little bit. And over time, the students are going to see, oh, in 230, there's 1 0. In 2300, there's 2 zeros. And in 23 times 1,000, 23,000. After building the 2 models and then doing one with just numbers, they should begin to see the pattern of zeros when multiplying by 10. We can then remove the models and use properties of operations to multiply. 30 times 100 can be 3 times 10, there's your 30, times 100. Now we can make this 3 times 1,000. You see where that came from? The 10 times 100 is 1,000. 3 times 1,000 is 3,000. 630 times 100 can be decomposed into 63 times 10 times 100. So then this becomes 63 times 10 times 100 equals 63 times 1,000, which is easily computed as 63,000. Let's look at 240 times 300. we can multiply the non-zero digits and then add the number of zeros back in. 3 times 24 is 72. Add back in the 3 zeros. Your answer is 72,000. We can use the same method when working with decimal numbers. Let's build chip models of a decimal number. Let's build 4/10, and let's multiply that by 10. Students are doing this. So 1/10 times 10 is 1. 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 Have them record what they did here. 0.4 times 10 equals 4. Now let's multiply 4/10 by 100. 1/10 times 100 is 10. 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 Have the students record what they built. 4/10, 0.4 times 100 equals 10, 20, 30, 40. And we'll do the last one with numbers, and we won't build it with the chip model. So 0.4 times 1,000 this time. And we'll ask the students, look at the pattern of the decimal point in these two problems and see if you can determine what the answer will be. And they'll understand that it's 400. After building the two models and then writing one problem out, the student should be able to see the movement of the decimal point when multiplying by 10 or multiples of 10. And we can remove the models and use the properties of operations to multiply. Let's look at 2.4 times 40. This can become 2.4 times 10 times 4. 2.4 times 10 becomes 24 times 4 equals 96. The same models can be used for discovering the movement of the decimal point when dividing by 10 or multiples of 10. Okay, on to Standard 5, NBT 3. Students have some experience reading and writing decimals from their work with fractions and decimals in 4th grade. They also know that 0.1 equals 1/10, and that 0.01 equals 1/100ths. Use 100th grids for teaching hundreds. Give students a 100th grid and have them shade in the first column. Ask them what number it represents. You're probably going to get two responses, 10 100ths or 1/10. Remind students that these are equivalent. On the same grid, ask students to shade in another 600ths. Now they can shade them in wherever they want, it doesn't matter. Have the students share their drawings with each other and with the class. Grab a few to project on the document camera or to just hold up. So what did we end up getting here? We started with 10 100ths. We added 6 100ths. And when you add those together, we get 16 100ths. Let's look at that in decimal notation. 10 100ths is equivalent to 1/10, so that's 0.1, plus 6 100ths, 0.06, equals 0.16. That's why we say that as 16 hundredths, because the denominator is 100. Comparing two decimals is done as it was done with comparing whole numbers. We begin at the left and we look at the digits in each place value and compare them. In 23.54, there's a 2 in the tens place. In 23.56, there's also a 2 in the tens place. So we can't compare there. We have to move to the next place value, which is the ones. We have a 3 in the ones over here and a 3 in the ones over here. Have to keep moving because they're the same. A 5 in the tens place and a 5 in the tens place. Have to move one more time to the hundredths place and notice 4 hundredths is less than 6 hundredths, so this whole number is less than this whole number. Now, what can trip students up is a problem like this. 42.54 and 4.236. When we start at the left and compare, we have 4 tens in this number and no tens in this number. That's something the students will often have trouble with, thinking that this is a tens place because of the number of digits. So 42.54 is greater than 4.236. Let's move on to standard 5. For the first time, the formal algorithm for multiplying multi-digit whole numbers will be introduced. Students did extensive work in 4th grade multiplying numbers using place value knowledge, properties of operations, and models. The algorithm will be taught drawing on all that they have done previously, and this shortcut should be well received by the 5th graders. Students have used place value charts before to do multiplication, but now we're adding the algorithm alongside of it. So we'll set up the number, 2 tens and 1 1. And then we'll tell the students to multiply 4 times 1 and represent that in the model. 4 times 1 is 4. And then we'll ask them to multiply 4 times 2 tens. 4 times 2 tens is 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. Now we'll ask them to record what they've put in the place value chart on the algorithm. 4 times 1 gave me 1, 2, 3, 4. 4 times 2 tens gave me 8. 1, 2, 3, 4, 5, 6, 7, 8. In the next problem, we'll show students how to deal with rebundling from the ones to the tens place. Let's look at 48 times 2. So first, like we did in the last problem, we're going to build the number into the place value chart. 4 tens, 1, 2, 3, 4. 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to tell the students to multiply the ones place by 2. 2 times 8 is 16. So we need 16 ones in there. We have 8, 9, 10, 11, 12, 13, 14, 15, 16. And we hold there for a moment. And then we say we have to multiply the tens by 2 as well. So we have 4 tens multiplied by 2. We need 8 tens in there. We have 4, 1, 2, 3, 4. Stopping here, asking the students to turn and talk to each other about what they noticed in the model. They should come back to you and realize, hey, we have way too many ones in the one place. What are we going to do with them? So they know from addition that they can rebundle, right? So we're going to take 4, 8, 10, of these ones and add it into the tens place. Now we ask them to record how many ones they have. 1, 2, 3, 4, 5, 6, and that's why there's a 6 there. But we moved the 10 over. How do we record that? Well, where do you think we should put it? Where would it have to go? Well, it's got to go in the tens place. Okay, so we'll put it in the tens place up here. Now let's record what we have in the tens place. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 times 4 tens was the original 8 10 plus the rebundled 1 10 is 9. 48 times 2 is 96. Continue practicing this method with 1 digit by 3 digit and 1 digit by 4 digit, and gradually remove the model so they're using just the algorithm. Okay, on to standard 5, NBT 7. Because of the uniformity of the base 10 place value system, students can use the same models and drawings and strategies based on place value and properties of operations that they use for adding, subtracting, multiplying, dividing whole numbers for operations with decimal numbers. Let's start with addition and subtraction. Students should first gain experience adding and subtracting decimals using concrete models. Let's use a place value chart and number chips. Have the students build a number 2 and 15 hundredths, which is 1/10 and 5 hundredths. And then have them write that first number. We're going to work horizontally. We're not in the algorithm yet. 2.15. And now we want to add 3 and 36 hundredths. So that's 3 ones, 3 tenths, and 6 100ths. 1, 2, 3, 4, 5, 6. And then have them write the rest of the problem. Plus 3.36. Now simply have them use the model to find the answer. But let's see what happens. So tell the students to write the answer. Okay, it equals, I have 1, 2, 3, 4, 5 ones. My decimal point, I have 1, 2, 3, 4 tenths. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hundredths. So what's the problem here? We have too many hundredths. So what happens here is we simply bundle up 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we trade them in for a tenth. Now the students count up their number again. 1, 2, 3, 4, 5. Good. 1, 2, 3, 4. Oh, that's right. Since we bundled 10 100ths and added a tenth, we have to change our 4 tenths to 5 tenths. So our answer, 2.15 plus 3.36 equals 5.51. This is a difficult problem because we had a rebundle, but this will help students when we move away from the chips. Let's try a subtraction problem. 6.05 minus 2.19. Now again, I'm using a difficult problem for demonstration purposes, but obviously you want to start the students off with problems that don't involve rebundling. So 6, 2, 3, 4, 5, 6. No tenths and 5 hundredths. 1, 2, 3, 4, 5. No tenths and 5 hundredths. Okay, so now we have to subtract. Students understand subtraction is taking away, and that's why I like to use these chips and the place value chart, because they can physically pull them away. So starting in the hundredths place, we have to subtract 9 hundredths. The problem the kids are going to see is that they only have 5 100ths in the hundredths place, so we need to make some more 100ths. We can't make them from tenths because we don't have any. So we have to start with the ones. So we'll take a 1, and we'll make 10 tenths. 2, 4, 6, 8, 10. Now that we have tenths, in the tenths place, we can make hundredths out of tenths. So we trade in 1/10 for 10 hundredths. 2, 4, 6, 8, 10. Okay, now we're okay because it says subtract 9 100ths from the hundredths place, and we have 15 in there because we made 10 more out of the tenths. So we're going to take out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. How are we looking in the tenths place? We have to subtract 1. We have plenty of them, so we take that away. In the ones place, we have to take 2. We have plenty. We take 2, and now the students can simply read their chart and understand what the answer is. 6.05 minus 2.19 equals 3.1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Note that the same modeling can be done with base 10 blocks on the place value chart if you prefer those. After these experiences, students should move away from using concrete objects and begin experimenting, adding and subtracting decimals with place value knowledge and properties of operations. Hundreds grids are good models for multiplying and dividing decimals by whole numbers. Use examples with products and quotients less than 1 and greater than 1. For example, look at this model. 0.13 times 3. Have the students shade in 13 hundredths 3 times and have them use different colored pencils or crayons so they can keep track of their 13 hundredths. Then they can see this is 1 13 hundredths, the green is a second 13 hundredths, the blue is a third 13 hundredths, and then just count it up. 10, 20, 30, 9 hundredths. 13 hundredths times 3 equals 39 hundredths. And then you can also see the division. 0.39 divided by 3. So we have 0.39, and we want to divide it in thirds. They can see that each part would be 0.13. Now, this is another interesting problem. We take this chart away, and let's look at this chart. Here, we're multiplying 0.65 times 3. So the student will start coloring 0.65, and then start to do the other one and realize, I don't have enough squares to color in. That helps them understand that we're moving past the number 1 for this problem. So they have to grab another hundredths chart, pull it over, and continue coloring. And then they can see that the answer is going to be 1, and 1, 2, 3, 4, 9, 5 equals 1.95. And as with the previous problem, they can also see the division. 1.95 divided by 3 will give you 3 groups of 0.65, which they can see with the different colors. Also, 3 times 0.65 can be converted to 3 times 65 by multiplying 0.65 by 10 twice. Students already know that this results in moving the decimal point 2 digits to the right. So this becomes 3 times 65, because we multiplied by 10 twice. The product of this is 195. But because we multiplied by 10 twice to make it a whole number, we have to now divide by 10 twice to get our answer. And that results in a move of the decimal point 2 places to the left. 1.95 is the final answer. Multiplying a decimal by a decimal looks like this. 3.4 times 0.6. What we want to do now is convert both of those decimal numbers to whole numbers. So this becomes 34 by multiplying by 10 times 6 by multiplying by 10, and our answer is 204. But again, we multiplied by 10 once, by 10 twice. To get back to the real answer, we have to take 204 and divide by 10 twice, undoing what we did previously. And this results in a move of a decimal point 2 places to the left, and our answer is 2.04. Here's how we can do dividing by decimals. Ideally, we want to be dividing by whole numbers because it's easier. The 30 we have, we're all set. The 0.1 we can turn into a whole number by multiplying by 10. But if we're going to multiply 0.1 times 10, we have to multiply the 30 times 10. So let's see what that looks like. 30 times 10 divided by 0.1 times 10. And watch how easy this makes this. 30 times 10 equals 300 divided by 0.1 times 10 is 1. 300 divided by 1 is 300. Now, if we have two decimals, 0.3 divided by 0.1, now we have to convert both to whole numbers. See what that looks like. 0.3 times 10 divided by 0.1 times 10 equals, move of one decimal place, 3 divided by 1 equals 3. Remember that all these concepts can be introduced in the context of real-world problems. Let the students experiment and share solutions with each other and the class. As the teacher, your job is to facilitate discussions about the merits of solution methods and to clarify misconceptions. You will have noticed that much of the work in this domain was built on the foundation of work done in earlier grades. Fifth grade is a big grade for consolidating concepts that were painstakingly developed beginning in kindergarten. Coherence of the Common Core curriculum enables teachers to slowly develop concepts over the years and prepare the students for the more sophisticated work they will do in middle school. Thanks for watching this Math Studio Talk. We hope that you enjoyed it, found it meaningful, and learned a thing or two to take back to your classroom.